Oh, the music's not working. Okie dokie. Let me do something real quick here. And then let me check and see if the beat and my voice are working. Check and see if the beat. Okay, seems to be working. Okay, so I've got my exciter in a good place. Let me just show you what it looks like. Okay, so as far as the DSP goes, everything is linked up to the dials, and as far as I can tell is working properly. Saving and recalling is also working properly. Phase and oversampling seems to be working. I'm missing a couple things that I usually put on my plugins. I need to probably reduce the size of all the components a little bit and put my little header bar. And I still want to try to do something right here with either, man, I don't know. I think I want to do like a little spectrum analyzer with a oscillator to kind of show you what's happening. The only thing is, I don't know how useful that really is to have like a spectrum view with like a sine wave. Let me put my multi-stream chat window up. Yeah. Well, at the very least, I want to move everything down and put my header component. And that I have in an actual component, so it should be easy to just copy from another project. So I guess I'll go to the BT Clipper. Source, probably UI components. Yeah, the header component. Okay. And this one is called Stimulate, but for some reason the project is called Exciter, so very good job, me. I guess I'll make a folder. Okay. So then in here, I just gotta go add existing, and then I'll do components, which only has the header in there. And then reopen it again in Xcode. That's the logic you have to do every time you add files to your Producer project. Okay, so how did I do this in BT Clipper? I probably... Hold up. Let's see. I want to check out the main. I'm guessing resize. Okay, so window header component. Okay, so apparently I did header component set bounds to this, and then the other components kind of top margin. Yeah, okay, so it looks like I made the header smaller than the top margin so that it would fit, and that would probably work again. So I guess let's just try it out. I guess I'm gonna go to the plugin editor header, and I'll have to include that component that we copy and pasted. And by the way, chat, if you have a question about something that you want me to explain about Juice, I have no problem completely diverging from what I'm doing and doing something that would be helpful. What did I call this? It's in UI components and it's called header. Yeah. Okay. And then all I have to do, I guess, is say LV header component header, and then go up here, or I guess actually go to the constructor, and I'll say add and make visible so that it actually appears. So header, and then let's see. Oh, it doesn't like something. Add make visible header component. Yep. Let's see. Header component. Doesn't seem like it needs anything special, so why? Oh, interesting. Oh. Yeah. Okay, so I can do this. Hold up. Okay, I can get rid of these. Those are like the menu components that were in the other project. And I don't need that. And I need to go back into the CPP and get rid of pretty much everything. That footer, don't need any of that either. I think that should do it. Okay. Oh, apparently header has a, yeah, I was passing it the tree and I don't need that anymore. Because that was for the menus, so I'm gonna get rid of that. And, is that it? I didn't do resize, so it's not actually gonna come up on the screen, but I just wanted to build. Okay, so build, so we know that nothing's wrong with the logic and the way it's set up. Okay, so we're gonna go to resize, and what is my top margin? Top margin is, okay, so the same thing as BT Clipper, so I should be able to just do the same thing. with, I don't know. I have this thing in my components. I have like set width and height. I forgot why I did that, but I'm just gonna include it just in case. It might be something that's unnecessary, but this is called, oh wait. I need header. That's what I need. Okay, let's see what happens. Okay, I just need to push everything down a little bit. So maybe make the top margin, I don't know how much I need to push it down by, but maybe like that. And then the dial size probably needs to come down. Okay, cool. So the dials look good. I need to push the rest of these down. Why are these? Okay, so phase and oversample and this little analyzer part are not on the same Y position apparently, because changing the margin didn't do anything. Wait, so I need the buttons, these two. The Y is, okay, so the analyzer is top margin, okay. The dials are top margin also. Okay, so since they're on top, that's why. So, okay, yeah. So what I probably should do is, okay, what I should do, I don't know what I should do. Let's see. Okay, what I should do is put the buttons on the same Y position as the dial. No, because that would put it right here. Okay, so I just need to push the buttons down a little bit, because this is probably still fine. Okay, let's just push the buttons down a little bit. So, analyzer get Y minus top margin, which would give you the top. So subtract more from it. Oh, wrong direction. That's let's see. I don't know. It's off maybe by like a little bit. Yeah, that's better. Now, one thing I will say is, since I'm on desktop and I have wide monitors, it's a good idea before I release it to check how the UI looks on like my laptop and make sure it looks good on the laptop, because if it looks good on the laptop, it'll look good on a big screen. So the problem is that if it's too small, these dots will disappear, and then the dial size ratio compared to the track looks weird. So it's just good to check it on mobile. And does this link work? Oh, there's no link. Hyperlink, web link. Okay. Where's the link? Oh, wait. That doesn't need to be in the paint method. Perfect. And is it the same width as the image? Yeah. Okay, cool. So that works. Okay, cool. So that's good. Is that all I wanted to do? I don't need... You know, I guess I could put the buttons in the header. Nah, it doesn't matter. I think this is fine. Okay, so here comes the fun part. Here's what I'm thinking for this little analyzer area. If I go... Sure, yeah, I'll go in Logic. It'll be easier. Okay, cool. So what I'm thinking is we're gonna make another channel, and let me mute it, and I'm gonna put a test oscillator. Yep, and I'm gonna put it at like 1500 or something over 1000, and pull up Logic's EQ. Yeah, you can already see let me put the mix all the way up. Okay. So we pull the mix all the way down. So this is with nothing, right? So if we have a spectrum analyzer, like an EQ analyzer from like 20 to 20,000, when you have a sine wave, it just looks like this, right? And the whole point of this plugin is that it adds harmonics, and you can see that it actually does that when I pull the mix up. So if I pull odd up, we get an odd harmonic there. We pull even, we get even there. And let's pull odd back up, so you can see we only see like one harmonic, but if we pull the amount up, we start to see other ones. So that's kind of the point of this plugin. So I don't know if this would be a realistic, useful thing for the user, because I mean, it kind of gives you a representation, but oh, you know what I could do? Actually, yeah. So I could make the oscillator have the same frequency as where the knob is plus a certain amount, so that it always shows, you know, in the actual range that you're working with. That makes sense. Yeah, I think I'll do that. It's not super difficult to implement an analyzer like this, and I've done it before. It's just going to be some copying and pasting from other projects. So actually, do I even have it on my computer? It might just be on my GitHub. Let's see. Yeah, I probably took it off. Let me go to my GitHub real quick. Like I said, chat, if anybody has any questions about anything juice related, I definitely would enjoy helping you with that, answering questions, doing any kind of demo instead of just doing this stuff. I just couldn't think of a topic for today. It might be this one. Wait, updated on July, August. Why do I have two? Let's see, analysis scope. Okay, that's the oscillator one. But did I also, where is the plugin processor? Okay, does it have a FFT in here? Yeah, it does. So this is, yeah, so this is the spectrum analyzer one. Okay, so I guess I'll just start. Okay, so this is the important stuff right here. So I'll put that in the plugin processor, and I had it in public probably because, yeah, you need the UI to be able to access it. Okay, and this. Very good. I'm gonna use this. This is just a sine wave oscillator right here. I will use that. This is not important. Okay. And then let's go to the processor. Is there anything in the? Yes. I'm gonna put that in the constructor. That's for the scope. That doesn't matter. See anything prepare to play? Actually, no. Interesting. And let's ignore the process block and get to the other stuff. Yeah, we need this. And that. Okay. Just two methods that we need. Where should I put them? I guess I'll put them under the process block. I could put them in another file, but it's not like it's that much. And I need to change the class names. That So push next sample, draw next frame. Draw next frame. Push those. Oh, I guess those are the only two methods. Okie dokie. And I guess now we can move to the, yeah, let's just do whatever we need for the process block. So it looks like all we do is scope, show spectrum, if buffer, white noise. I have no idea what I was doing for this. Push next sample into FIFA. Okay, so we just need to, in the sample by sample stuff, we need to put this. Okay, so okay, so I guess if I just do this, let me go to the main block here. Okay, push next sample into FIFO, and then we'll do data sample, and that should be it. So that'll be the test to make sure that it's working, and whenever that works, we can create a, we can probably create another audio block that's just holding the oscillator, and then we'll push that and then never apply it to the output. I don't think that'll be a problem to do, but yeah, let's just keep going. Okay. Oh, looks like we might have a build error, so let's see. Oh no, it's good. Oh no, we got one. Use of undeclared. Yeah, this is probably not original. In fact, let's go check on the juice tutorial. I'm pretty sure that's one of the tutorials online. DSP, visualize this. Okay. So let's look for the code to draw, which is this. Ah, okay. Scope size times that. Is that build? All of this code right here is what skews the scaling from 20 to 20,000. It doesn't draw the lines and numbers for you, but it handles showing the frequencies at that skewed logarithmic scaling. And I'm sure there's a simple way to use this data to create the little lines and numbers on the GUI, but I'm not that smart, so we're just gonna keep trucking along. Okay, and then we have to do something in the GUI, right? So we're gonna have to go to the plugin editor. See, is there anything we need to declare? So yeah, we need the timer. Okay. Okay. So let's just get the timer call back in there. Editor. We also need to inherit from timer. Let's align that to look nice. Okay. That's not super important, the color. We can do that after. I don't know if draw frame is super important. Let's see. Does anything else in here have to do with the... Nope. I think that's it. Let's check out what draw frame does. It might be redundant. We can start timer. Go ahead and do that. Constructor. Start timer. And let's see, it's gonna be... None of that's important, so let's check out paint. So it's gonna say, you know, Python trying to prove the Beal conjecture. Python how to find common prime factors of 3 numbers. I don't really know Python that well, but don't know how to find common prime factors of 3 numbers. So you want to write a method that takes in 3 numbers and finds the common prime factors between them? Well, let's take a look. I'm going to look it up in C++ first so that I understand it, and then let's see, find... This is 2 numbers, might be able to... Create a Boolean array and initialize all entries. It's true of value in prime I will finally be false if I is not a prime. Oh, memset, this is old. Oh, well, if it's never been proven before, I doubt that I can do it. Thanks for the follow. Oh, 2 follows, thanks. Oh, this doesn't look hard. Wait, find the common prime, get the greatest common denominator of the given numbers, and that, find the prime divisors of that. Yeah, I'm just reading it in C++ so that it makes more sense to me, but it probably doesn't matter. Yeah, it's pretty much the same thing. So we have a function, common prime. Wait, where is this? Wait, where is this defined? GCD of A and B. Wait, is this in the standard template library? No. Did I just miss where it was defined? Well, anyway, this doesn't look hard. Prime is equal to 2 times that, which is that some kind of bit shift thing? Oh, well, this makes it easier for Python, because they're importing they're importing greatest common denominator and square root from math. Do you want me to just send you this? Trying to look at it to see if you can just add in another argument to have 3. Look like you'll probably have to switch this 2 out with a 3. And then multiples of P is non-prime. And then do ABC. ABC 3 and then do ABC and then pick your 3 numbers. You think that'll get you going on this? Cool. I'll leave that up just in case. Okay, and then draw frame, which does what? Where is draw frame? Why is this formatted so poorly? Let me copy this over. Draw frame, I'll put that in here. Header, which does not have a default constructor. Yes, it does. Cider. That, and then I don't know why there's so many spaces right here. That, and we're gonna say yes, I hear you. Yep, we all hear you. Void draw frame. And then we do that in paint. So I'd go here and I'd say draw frame G. And then where is it actually putting it? Here, whatever this scope is. So I need to change that to, oh, I just wanted it to tell me if they have a, yeah, that'll help you. Because like, the thing is, you need an algorithm like this to do it, because what if they don't have a common prime number until like really high, then you wouldn't be able to just kind of do it by hand. So this scope thing, let's figure out what this scope thing is, change it to spectrum, and then put that in there. Scope.setBound, so I'm gonna need that. So I guess scope is just a triangle. I mean a rectangle. Let's see. This is the constructor, so I don't see add and make visible scope. So it must just be a rectangle. Let's check this out. Let's see. Where are you at? right here, scope. I'm gonna take spectrum window. Put that right here. I guess I'll put it under draw frame. And I need to remember that I'm taking all of the scope references, not like an editor, scope. Why is that in the paint method? What? Why do I have scope that set bounds in paint with one set of coordinates, and then I have it in resize with another set of coordinates? So let's go to, what am I doing? Resize. I'm gonna put it, I guess, under analyzer, but it's really called spectrum window. So let's do that. Spectrum window, and then go back to resize and spectrum window. A raised to x plus b raised to y is equal to c raised to z if a, b, c, x, y, z are all whole positive integers and x, y, z are equal to or greater than 3. And the question is if a, b, and c will always share a common prime factor. I don't know how you'd be able to prove it, because if they always share a common, because numbers don't end, you would have to just do it infinitely. Unless I'm thinking of that wrong. You'd have to like input every possible input, which is infinite, I would assume. Can I just do analyzer dot get bounds? Too few. Expected 4, have 1. Okay, so apparently I can't do that. Get x analyzer dot get y. This makes no sense, but that's what it says. Why can't I just say get local bounds? Why do I have to do all of this? No idea. And then does it build? Let's see, let's go here. Okay, it built. Let's see if it does anything. Oh, look at that. Why is all the higher stuff? It's like the scaling is off. Let me go back. I wonder if I messed this up. I wonder if I had, I remember I was messing around with it the first time I tried this, trying different like values for scaling. I wonder if I'd messed it up. Okay, no. Okay, so let's try this. Let's see, test oscillator. Okay. So that's 1600. And that's 20,000. Why is this scaling off so much? Yeah, that's really strange. Let me save that. Close logic. Let's see. So we know this is correct. Let me check the FFT order. Okay, they do 11. Okay, let's go through this and see if everything is the same. One left order. All that looks the same. Go FFT data. Scope data. Scope size. Where's that? Scope data. Oh, I have that. Okay, I have that public. Okay. Yeah. Blah, blah, blah. Yeah, this is doing it sample by sample, so that should be fine. I wonder if this is different. Draw frame. Oh, yeah. What would happen if I just replace this to the default? There's no X or Y. Does that still build? Scope size. Oh, audio processor dot scope size. Let's see. And then same thing for scope data, right? It's still really off. Because I can tell it's from here to here. And 20,000 hertz is like right here. Oh. No, this is the end, but for some reason it's drawing. Oh, it's because of oversampling. That's why. Okay. All right. Okay. All right. So. Let's go back to the way it was and make sure oversampling is turned off, and then we're gonna have to handle oversampling in the processor. Yeah, there we go. Okay. That is much better. Well, that's kind of cool. And if we turn oversampling on, it's going to get ridiculous. Yeah. Okay. We need to figure out how to handle oversampling. Let me go ahead and added spectrum analyzer. Now we have a place to stop if this oversampling thing gets out of hand. So where in all of that spectrum stuff does oversampling happen? Okay, so let me go to the constructor. Forward FFT.getSize. Windowing function. Nothing in prepare to play, right? Get rid of that. Oh, I don't see anything about sampling rate. Okay. Hold on just a second. I'll be right back. Okay, maybe it'd be better to look through this and see. Oh, and also, we don't need a high dynamic range. Rectangular. Let's try that real quick. Let's see if that makes any difference with the way it looks. I have no idea how to make a really nice looking one that you would see like on like Baby Audio's what's it called? That resonance one. No idea how to make that. And the only thing I think to make it look nice would be to fill it in. Oh, that's not what I thought it was going to look like. It's very strange. Oh no, we do need a lot of dynamic. Oh, yeah, because, yeah, okay. Blackman, that's the one. See what this looks like. Yeah, fine. And yeah, and now the changes are more obvious. Okay. So wait, hold up. Yeah, oversampling destroys it. So the thing is that I don't know enough about FFTs. Wait, does it just get size? What is size in the FFT? Wait, window. Oh, I bet if I change this number, I bet it would get. See what that looks like if I change it really low. The other thing is that if you make it too high res, it's probably going to use a lot of CPU or GPU or whatever it's using. Let's see what this low number looks like. Yeah, okay. It's terrible. Okay. So let's do 1024. And see if it looks any different from 512. If it doesn't, we can go back down to 512 and save CPU. Is it any better? I don't know, not really. So I'm gonna just go back down to 512, whatever. And let's see, FFT size. Okay, so let's go here. Use DSP, FFT, form. I don't see, oh, number of data points. Returns the number of data points that this FFT was created to work with. Thank you, Juice Documentation. What a great explanation. See anything about sample rate? It's also strange that there's no prepare function. You know what? This might not matter because we're going to be just putting an oscillator and not oversampling that block. Yes. Yeah, I don't think it'll matter. Okay. So okay, so what we'll do is go back here. to my thing right here. Okay, so we'll go to the processor, and I'm going to take the sine wave. Where's it at? Yeah, sine wave right here. And put that down here. OSC module is what it's called, I guess. Okay. And then I need to say okay, so I can't do set sample rate. I think we're still gonna. Oh wait, there's no prepare method. Yes, there is. Okay. So I guess I could make another process spec just for the oscillator. Yeah, you know what? I'm gonna do that. We're just gonna copy and paste this. Okay, that should be fine. And we're also gonna set the sample rate. I mean, not the sample rate, the frequency. So osc module dot set frequency to have a cutoff. Yeah, cutoff. Should I do add or multiply? Probably just add 100 and it'll always be in view. Ah. Right here. Okay, and then when I change the parameters, so in my this, yep, and we'll say osc module dot set frequency cutoff dot get next value plus 100. That should be good. Okay, and then I need to make another audio block. Oh, but I'm gonna, let's see. I need to pass it a buffer. But I don't want the buffer in it. Okay, create a 0 size audio block. Okay, so I could create an audio block. Okay. So let's say like osc block. And then we could say osc block. I do like set size. No. Okay. I guess I'm gonna leave it empty and just see what happens. And then what did I do in here to actually process it? Yeah, okay. Osc block. And then do a block loop and then put this there. Also, I need to change my little button setting for this, but it's supposed to be better to put the channel first, the channel loop first, and then loop through the samples. So we'll do, it needs to be based off of osc block. And this is outside of the oversampling logic, so that shouldn't affect it. It's a different block. Let's see what happens. Doesn't seem to be working. Osc module.process, osc block. Oh, and this one I was just muting the audio. Yeah, I think I just don't understand the using a block and buffer well enough to do this. Because if I set the audio block to buffer, then it's going to have the contents of that buffer. And I just kind of want to... Wait, what if I... What if I use my LFO? Yeah. Hold on a second. Let me go use the bathroom real quick and I'll be right back. It's your boy. Okay, what if instead of actually using audio, I use that LFO data class that I made? So, let me pull it up. Where's it at? It's in just the filter. Okay, so LFO generator. Prepare. Okay, and then set. And this is going to be cut off get next value plus 100, I guess. And I'm going to go put that in update right here. And then yeah, just do a sample loop. Okay. I'll just do a sample loop for the buffer. Buffer.get num samples, LFO process, and then I guess push into that, and I'll do LFO generator.get current float value. Something weird is happening. Let's ignore this. Just build and see if I messed anything up. Oh yeah, something's messed up. Oh, I bet it's using another process spec. No. Okay, weird. So we were having an issue with something being saved, but then also this back on. Oh, it looks like it's working. Oh gosh, it's working. Well. Well, now I need... What if I put it first? Yeah. Okay, so then the problem now becomes we need the processing to happen on this LFO data stuff, so yeah, I don't know, this is weird. So might be able to interleave it in here somehow. So we would need to say this dot process, and I guess do it first. And then what? Oh, well, actually, what if I base it off of this block? Does that make a difference? No. So what do I need to do? I need process to happen. I guess that would be first. But then I need push next sample into FIFO to be this whole DSP block on the LFO generator. So I could just do a process sample version. I feel like that would use a lot of CPU. So could I somehow interleave it in here? No, because I'd have to add more filters, because you can't use one filter to filter two different signals. If I make another process method just for this like LFO data, I'd have to make another set of filters, which would be more CPU, and then I'd have to do the two distortion algorithms, which I guess not that big of a deal. Well, what if I... Okay, this might be dumb, but I'm gonna try it just to see what it does. Another loop, and then I'll take this. For right now, I'll make it block. And we'll say data process, and we'll say this times data sample, I guess. And at the very least, this right here is whatever is in the block after our processing. So I bet it's just gonna look like noise. Yeah. Oh, let me take this out. That's extra processing for nothing. Yeah. What if I combine them and flip the phase of the block data? Okay. Wait, what about plus? Well, that's weird. Oh, wait. Wait, what if I put this in there and take this, put it at the end here? Oh wait, hold on. This needs to be paired together, I think. Okay, and then let's have it not paired together like that. Okay. Let's try plus. Yeah. I'm not sure what to do on this one. I thought there would be a clever way I could work it in here, but okay, well, let me do this and see if the oversampling is still a problem. You know what? I wouldn't have to use the filters because it's just a sine wave at a single frequency. I don't have to worry about filtering things out, probably. No, I would. I think so. Maybe we just have to try and see. Let's see what it looks like right now. Oh, okay, oversampling doesn't mess with it. Oh, yes, it does. Okay. Not nearly as bad as before, though. So, yeah, I think I'm gonna have to write another version of this. Well, unless I did. Load, LFO odd and LFO even is equal to this, that, and then this. Oh, I already put it right here. LFO output signal is equal to odd even, and then I guess this would be the dry, the bottom band signal. And then I'm gonna take const out so that I could do this. LFO output signal times equals phase, so that's the same. And LFO out signal, I guess, is what I would put right here. Is that everything except for the filtering? I think it is. Odd. LFO odd. Okay, well, try that. That's some extra processing, but hey. Okay. It works. The only thing is every once in a while there's some weird stuff right here. So I think I would, yeah, I'm gonna need to do a high pass filter. And then that should be it. I can't believe that worked. Okay, so everything below this point is just for the what am I trying to say? Just for the non-audio spectrum. Okay. And I'll need another filter, just one more. Okay, so let's take what am I using? Yeah, let's do another Linkwitz-Riley filter. And I'm just gonna say high pass. High pass filter. Yep. Go to prepare. High pass filter. Prepare with spec. And we need to set the type. Which is a high pass. We need to make sure that it's handled in update parameters. So where are the other ones at? Oh, it's just cut off. Okay. So we just need to say high pass filter set cutoff. Cutoff. And then what about, yeah, this is what I need also. High pass dot prepare spec. And then high pass dot prepare spec. Yes, I hear you. And is that the same amount of stuff as the other filters? It looks like it. Okay. So then I think I could just do this. I'll go get rid of that. Oh, I'm stupid. Let's take this out because that's already handled for us in update parameters. Right? Yes. Okay. Let's make sure. Yes. Okay. And then we just need to call the actual filter. So if we go right here and we'll say high pass filter dot process sample. So the channel, which right now is that, and then this, and I think we are good. Okay, it looks like I need to adjust the cutoff. I also need to lower it, it seems. Okay, let's save that. And what was I gonna do? Oh yeah, change the cutoff. Okay, so you know what I could do? Times 1.25, and then for the high pass, do times 0. I don't know, 8 or something. Okay. That's really weird. Yeah, something about oversampling breaks it. Not sure what that's about, but yeah. Okay, whatever. So another thing I need to do is this. Okay, so this. Okay. X height is actually going to be get height. Okay, and then we need to multiply it by a little bit, 0.9 or something like that should work, right? It's still going over. Oh, it's the Y. Starts. Yeah, so do I need to do this? Oh, that seems perfect. Although the width seems off. That's weird. The width is... I don't know, maybe I need to multiply that by something also. What? Okay, well... What? That makes no sense. Okay. Bro, what? You're really gonna make me do this? Okay. This is what I'm gonna do. Okay. And why? Why? Why to type int? Is that necessary? Bro, what? Bro. Why did the tutorial not have an X and Y position right here? We try this again and see what happens. Spectrum window. What? So JMap wants you to explicitly. Oh, wait. Is this why? Oh, wait. That one. Bro, what? What do you mean? Okay, well, does that build? No, it doesn't. The tutorial code doesn't even build. Oh wait, it's because of the audio processor. Scope data, scope size, scope data. Does that build? Okay, let's see if we can see all the way up to 20,000 hertz. Let's pull all that down. So that's 1,000. And 20,000 is still off of the screen somehow. Very good. So we've got X, Y. So this would be width. X, Y, width. What if I just multiply this by something? Bro, how is that a no matching function call to JMap? What if auto new width, I don't know, is equal to static cast to float to make sure that we're afloat, that we put new width right here. No way. I'm casting it to a float. How could that be? Why is width okay? Bro, I don't understand this. Can I subtract something from it? Also, let me explicitly say float. Bro, I don't know what this is. This is stupid. Or I'm gonna lose my mind. Because JMap, using this one. Let's type. Wait, maybe they just all have to match. They don't necessarily all have to be floats. Maybe they just all have to match. I don't understand why this is so difficult to just change the width. I don't understand why. First of all, why by default it doesn't show all the frequencies. I could change the scaling in the in here. Where is it? This is 0.2. Let's do 0.1 and see what happens. That's worse. Okay. So this might work eventually. I don't know. Oh, that just doesn't work. Okay. Yeah, I don't know. This is crazy to me that this isn't working. But if I go back and pull the original editor, this, I have no idea how did I do this? That doesn't seem like something I would have done on my own. Spectrum window. Okay, so whatever. I'll have to work on that in the future. But for right now, the quirk is that frequencies above like 15,000 hertz don't get displayed for some reason. really above like 10,000. Stops at like 10,000. This actually make it better. So that was like 7,500 to 8,000 at the end. Does it actually get better, or is it just the scaling that's changing? Yeah, it does get better. Problem though is that now 1,000 is all the way at the bottom. Well, that's not an issue because my lowest value is 1,000. So what happens if I make this like 0.5? Seven five. Interesting. Very interesting. And then last but not least, we need to go into here and say if OS toggle is off. Now, what happens when you turn it off? Does it just stay right there? Okay. Yeah. And if I turn it back on, yeah, okay. That probably works. Let's save it like that and recall it. Very strange, but when you toggle it back on, interesting. Okay, well, the only thing I really have to fix is that weird graphic we saw whenever loaded it up, but besides that, that's probably good enough. Spectrum for LFO is working. And that is it. If you stuck with me, good job. Thanks for watching. I will be back Wednesday. Let me get my stuff in order, and I will see you then. Thanks.